Relativity. Einstein's transformations. In the 19th century, James Clerk Maxwell brought together the work on electricity and magnetism and brought them together in the theory of electromagnetism. He noticed that the interaction of a moving magnet with a wire could generate waves resulting from the reaction of the current created, which in turn created a magnetic field. Electromagnetic waves are discovered. Their speed corresponds to that of light, which confirms that light is even an electromagnetic wave. The result was a prodigious scientific advance. Waves needed a medium to propagate, so physicists of the time looked for this medium. The word wave comes to us from water. A pure wave, a shower, circles in the water. Sound is also a wave that propagates through certain materials and also through the air. Physicists will be looking for a medium that fills all of interstellar space. They called it the ether in honor of Aristotle. In his time, Descartes had imagined that the ether swirled around the sun and dragged the planets with it. Michelson and Morley sought to detect the motion of the Earth in relation to the supposedly immobile p-ether in the frame of reference of the sun and the supposedly fixed stars at the time, which was the fatal error. Woldmar-Voigt and then Lorentz imagined a contraction of matter with velocity, inspired by Heaviside's ellipsoid. Poincaré finalized the calculations. Lorentz understood that the contraction of lengths prevented the detection of the Earth's motion in relation to the ether. He saves the existence of ether. Lorentz in turn found the memes and Poincaré finalized them in a remarkable way. On the electrodynamics of bodies in motion, or Einstein's transformations. Einstein used relativity to demonstrate that he did not need the ether. He uses his effects, which had deceived Aristotle in his time, to rediscover the transformations of Lorentz without worrying about the ether. It allows him to prove that nothing changes in a frame of reference in motion. Since its motion is relative, we can at any time consider it immobile and say that it is the other frames of reference that move in relation to it. In addition, he shows that measurements made on a moving object cannot be simultaneous, which leads to distorted measurements. We have kept the Lorentz transformations that result from the deformation of the electric field of the electron, spherical at rest, which becomes an ellipsoid with velocity. This phenomenon was discovered by Heaviside. George Frederick Charles Searle calculated the root contraction factor of 1 minus v superscript 2 slash c superscript 2, which would be used by Lorentz for his transformations. They contract the lengths and slow down the flow of time of moving objects. Einstein's transformations. Albert Einstein demonstrated that measurements made on fast-moving objects are not simultaneous and cause measurement errors. To measure the position of objects in space, light is used to see them. To make exact measurements on a moving object, the position of its extremities would have to be measured simultaneously. Otherwise, while the light reaches the next point, it moves away from or closer to the previous point and distorts the result. The calculation made by Einstein gives the same formula. Root of 1 minus v superscript 2 over c superscript 2. It is Einstein's solution that is the right one. Did you doubt it? Special relativity, 1905. Einstein posits two postulates. 1. In the case of the influence of a magnet on a conductor, the phenomenon depends solely on the relative motion of the conductor and the magnet. This is the principle of relativity applied to electromagnetism. 2. The speed of light does not depend on the speed of the object that produces it, so it is a universal constant, the same in all frames of reference regardless of their speed. He specifies that his first postulate contradicts Maxwell, who has two equations, one for the movement of the magnet, Faraday, the other for that of the wire, Ampere, but they give identical results to the first order. The second postulate contradicts the first. A constant velocity that is the same in all frames of reference in different motions is not a relative motion. He underlines the problems posed, the great class. Evidence that Einstein did criticize his assumptions. Article from 1905. First page. It is known that Maxwell's electrodynamics, when applied to moving bodies, leads to asymmetries which do not appear to be inherent in the phenomena. Take, for example, the reciprocal electrodynamic action of a magnet and a conductor. The observable phenomenon here depends only on the relative motion of the conductor and the magnet, whereas the customary view draws a sharp distinction between the two cases in which either the one or the other of these bodies is in motion. There is a different equation Faraday or Ampere depending on the object that is in motion with respect to the laboratory's reference frame. Further, we will raise this conjecture, the purport of which will hereafter be called the principle of relativity, to the status of a postulate, and also introduce another postulate, which is only apparently irreconcilable with the former, namely, that light is always propagated in empty space with a definite velocity, c which is independent of the state of motion of the emitting body. These criticisms did not discourage him, he was right. We will offer an explanation. Chapter 1 Kinematic Part Paragraph 1 Definition of Simultaneity. The notion of simultaneity is fundamental for the measurement of objects. An observer placed at A with a clock can assign a time to events in the vicinity of A. With a clock set at B, an observer at B can do the same. For an object at rest, the time it takes for light to go from A to B is equivalent to the time it takes for it to return from B to A. During his journey, nothing moves. The quantity 2AB on TA is prime minus TA is a universal constant, the speed of light in a vacuum. Paragraph 2. On the relativity of lengths and times. Let be a rod AB of length L, at rest in the frame of reference small k, which is in motion at the speed v with respect to large K. A. An observer shall move with the rod as in paragraph 1 and measure its length. He is at rest with the rod to be measured. The length L is unchanged. See paragraph 1. B. An observer of large K determines at which points of sound. Referential are the ends of the rod to be measured at time t, using the clocks of K. When the light goes from A to B from large K, he sees B moving away. TB minus TA equals are AB on big V, small v. When the light returns from B to A, he sees A approaching. T premium A minus TB equals are AB premium over grand V smaller v. Einstein takes the average of the round trip as the length of the ruler. End of the first stage. Einstein transferred the measurements made on the rule AB in motion with the frame of reference small k into the frame of reference large K. Stationary large K system with x, y, z, t, and the small k system in motion of coordinates in Greek, letters that moves parallel to large K along the x-axis at the speed small v with the rod AB. A point KSI in small k moves at the speed minus small v. KSI prime equals KSI 0 minus small v, then multiply time tau. The projection of this point on the big K is x prime, which is always immobile in big K. A ray is emitted at time tau 0 from A to B. It is reflected at time tau 1 to A and arrives at A at time tau 2. With respect to large K via x prime we have half of time tau 0 plus tau 2 equals time tau 1. Einstein uses quadravectors x, y, z, and t for points at times tau 0, tau 1, and tau 2. The following two formulas are the starting point for calculating the equation that will result in the root of 1, v superscript 2 over c superscript 2. The rest, in Einstein's article for physicists and mathematicians. Thank you. Einstein's AB rigid moving rod. Looks like the interferometer arm. According to previous calculations, Einstein. Find the same formula. Root of 1 minus v2 over c2. He demonstrated that the speed of the moving object, in this case the Earth, causes the phenomenon of non-simultaneity of the measurements, which distorts the lengths and makes it appear that the measured distances are contracting. We cannot say whether Einstein was inspired by it. The lack of detection of the Earth's motion relative to the ether led Lorentz to apply his transformations. Einstein found them by applying the equations for the displacement of light, which here runs after B, which moves away at B prime, and returns to A, which approaches at D. There is no contraction but desynchronization of the measurements if we follow Albert's reasoning. The paradox of the twins. This paradox results from the fact that few people know what Einstein wrote and what the relativity of motion means, otherwise there would be no paradox. 3 interpretations. 1. Seen from Earth, the traveler ages less quickly since the information received is desynchronized by the speed. 2. From the traveler's point of view, the principle of relativity tells us that it is the Earth that is moving away, and in the same way, he sees time passing more slowly. 3. As it is the time taken by light to measure the distances to the distant object, these mirages cancel each other out on the return, and they are the same age. These debates prove that the relativity of movement was poorly understood. Einstein explained that the traveler ages less because of changes in reference frames, the time of acceleration or braking, and the U-turn. He did not try to clarify, probably annoyed at being misunderstood. Note that under lower gravity than Earth, 9.81 meters per square second, the traveler will age faster and come back older. Twins in space-time. Everything is law. Everything is love. It's all money. Everything is sex. You should know it. Everything is relative. Why is the speed of light the same in all frames of reference? This is Einstein's second postulate. We have a hypothesis which, at first glance, is absurd, as Einstein would say. But not discouraged, like him, we say that it stems from his general relativity. This is the application of general relativity to bodies in free fall, and we propose to apply it to the ether. Einstein's that made him interact with matter, and to which he had not been able to attribute any movement. It would be in free fall with all the celestial bodies it accompanies. The speed of light is then locally the same in all these frames of reference.